Welcome again to Mr. Benjamin's Math World. We have been asked to factor this expression by using the Ruffini method. And I have to use Ruffini because first, it's not a trinomial that can be factored as a perfect square trinomial or as a non-perfect square trinomial, or factor it by completing the square, or factor it by using the quadratic formula. So I have 4 terms here, and I need to factor this. How do I factor this type of expressions by using the Ruffini method? First thing we need to keep in mind is that we need to make sure that the expression is organized. It is in order. What do I mean by in order? Well, from the greatest exponent to the lowest one. This is to the third power, to the second power, to the first power, and no variable. So it is in order. That's our first step. Make sure that the expression is already in order. So what do I do? How can I factor this? Well, number one, we need to get the factors of the independent term. It has no variable, this term. We need to get the factors of this number, the number 6. The factors of the number 6 are 1, because 1 times 6 is 6. 2, because 2 times 3 is 6. 3, because 3 times 2 is 6. 6, because 6 times 1 is 6. But we also have -1, -2, and -3. These are the factors. So these are the numbers I'm going to be using to solve this. Yes, we need to try until we get remainder 0. And I'll show you how, and I'll show you where. So what we do is we copy the coefficients of the expression. 1 is in order. The first coefficient to the third power is 1. And then we take the second coefficient, including its sign, which is a -6. And I get up 11 and a -6. And I'm going to try each one of these factors here. I know what the answer is, so but I'm going to use one that does not give us a remainder 0, just to show how it is. I'm going to use, for example, the number 2. So what we do, we use the x equals 2 here. I'm going to try the number 2. I'm trying this factor. This is from where you get the numbers you're going to be testing here. So I decide to use the number 2 first. So what we do, the 2. We bring down the first number here, and we play a little game. Times, subtracting, adding. Times, subtracting, adding. Like this. Once you bring down the first number, we multiply. 1 times 2, both are positive. So I'm saying +1 times +2, which is 1 times 2, is equals to +2. And here we saw what it says. It says -6 plus 2 is -4. And then again, once I get this result, I go back to the multiplication. -4 times 2 is -8. 11 minus 8 is 3. 3 times 2 is 6. +6. This is one of the results. So -6 plus 6 equals to 0. I got. Once you get the remainder 0, this is one of the solutions. This is one of the factors. The number 2 is a factor. So if you get x equals 2, it means that the factor is x. Attention to this part. I'm moving the 2, which is a positive, to the left is -2 equals 0. So one of the factors is x minus 2. When I say factor, I mean this. You see 20, for example, is 5 times 4. This is a factor of 20, and this is a factor of 20. So what I've done is I've gotten one of the factors of this expression. Now, which one is the second one? Once you get this result, this term will be my first term, the x. So I bring down the x. But instead of being to the third power, it decreases in 1. If it's to the third, I will have 1, that's a 1 here, I don't have to write it down, x to the second power, not to the third, to the second power. The second term will be the x to the first. It goes in descending order. So this will be minus 4x plus 3 independent term. This is the second factor because my first factor is x minus 2. It means that if you multiply x minus 2 times x to the second minus 4x plus 3, you're going to get this result. If you try, you'll see you'll get the same result. Now, have I finished? Not quite yet, because if you look close, you see that this is a non-perfect trinomial, and I might be able to find two numbers. When you multiply them, you get 3. When you add them or subtract them, you get negative 4. Do those numbers exist? Yes, they do. So what I'm going to do is I'm going to bring down the x minus 2, my first factor, which I found first. When I found x equals 2, it means that x minus 2 is 0, so I got the first factor, x minus 2. And then I'm going to factor this. How do I factor this? Bring down the square root of the first term in both parentheses. And now I need to find two numbers. When you multiply them, you get 3. And when you add them or subtract them, you get 4. You got the numbers in mind? I know you do. The numbers are 3 and 1. Because 3 times 1 is 3, and 3 plus 1 is 4. Now, I need to get the numbers that when I multiply them, I get positive 3. But when I add them or subtract them, because in algebra and mathematics, the signs tell you what to do. There's no addition or subtraction. The signs tell you what to do. The numbers 3 and 1, and the signs will be negative and negative. How do I know that? Well, because if I multiply negative 3 times negative 1, I get positive 3. And if I add negative 3 minus 1 is negative 4. Because when I'm adding, the rule says when the numbers have the same sign in addition and subtraction, when the numbers have the same signs, you add the numbers and you copy the same sign. In multiplication, this is negative times negative is positive. So I got the factors for this expression. When you factor x to the third minus 6x to the second plus 11x minus 6 equals 0, it is x minus 2 times x minus 3 times x minus 1 equals to 0. The solutions for that, well, since they are equal to 0, it means that I have 1, 2, 3 solutions because it's to the third power. You will have as many solutions as the greatest exponent is. 3 solutions. The first solution, x minus 2 equals to 0. The second solution, x minus 3 equals to 0. And the last one is x minus 1 equals to 0. Therefore, x equals to 2 goes positive, adding, x equals to 3, and x equals to 1. What does this mean? If you use one of these numbers here, or 2, or 3, or 1, if you substitute in here, you will get the result 0. So all these 3 solutions satisfy this equation. And this is the way you use the Ruffini method. If this video was useful to you, just feel free to subscribe and activate the bell in order to receive more notifications. See you next time.